Hello students, today's agenda is to check homework. We'll be graphing rational functions and you will be able to do 7.4. Today students will be able to graph simple rational functions with a single asymptote. But before we do that, just so that we made the connection, let's just do a warm-up related to the previous lessons where we were finding the zeros and then sketching the graph. So for the first factor we have x. That means that our 0 will be x equals 0 and the multiplicity is 1. For the next one is x plus 3. That means that x is at -3. So I'm going to put it over here, -3. And the multiplicity is 2 because it has exponent 2. The next one is x plus 2. That means that it's a -2, so it's closer in here. X is equals to -2 for the 0, and it's also a multiplicity 1. X plus 1, that means that x has to be -1 to make that a 0. And we want to keep them in order, so let me put the -1 in here, and then x equals 0 in here for this one, and then this from here. So the 0 was multiplicity 1, and the -1, which comes from here, is multiplicity 2. For the next one, x minus 1, that means that x has to be positive 1, because 1 minus 1 is 0, and multiplicity 1. So x has to be equals to positive 1 with multiplicity 1. And then the next one, you have x minus 2. That means that x has to be positive 2, because 2 minus 2 gives me 0, and the multiplicity is 2. So something that we need to review also is that for multiplicity 1, that means that wherever the point is, whatever it is, it crosses straight down through that point, or straight up if it's following the negative and positive behavior. If it has multiplicity 2, it means that wherever the point is, it might be here or here, but that means that it touches, my graph will touch at that point and then it bounces. Kind of like creating a parabola, okay? And we don't have any multiplicity 3, but if we did have multiplicity 3, that means that it touches at whatever that point is, but in a third-degree kind of curve. So it has this closer or flatter at near the point, actually, near the point where it crosses. So having that in mind, let's create our graph. And I'm going to make them a little wide so that we can actually appreciate those changes. So 1, 2, 3. And we only need up to 2, but that's okay. And -1, -2, -3. And what else do we need? We need the end behaviors before we can even graph the rest of our graph. Very redundant, but okay. So we have x times x. It's 2 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, and all of them are positive, so that means that my degree is odd degree. And we also have, since the coefficients are all positive, that means that we will have odd. Now if you remember from the previous, we came up with this table after analyzing the different graphs, and so we have here odd with positive leading coefficient. That means that the end behavior is going to go down on the left, up on the right. If you need to see this, we made the intro to end behavior in 7.1 and we continued in 7.2. At the end of this video, you will see the entire you will see the entire unit, and so it will be more clear. But yeah, if it's odd and positive in behavior, it goes down on the left, up on the right. And so that's very important to start with, okay? So we know that it's going to go on -3. That's the farthest point on the left. So this is what we need to have for our graph. And it's going to go kind of like that. So I'm just going to put my end behavior to the left of -3. And then the other one is going to be a +2. That's the farthest to the right. That's why I decided to make them in order to make it easier and see the two extremes. And so after the 2, I will have something like that going up. Okay, so that's my end behavior, where as x approaches -infinite, f of x is approaching -infinite. It goes down. As this goes to the left, my y goes down. And on the other side is as my x goes towards the positive infinite, then my y, or f of x, will go towards the positive infinite, okay? Or you just think down on the left, up on the right. Now that I have that, this is what I'm going to be doing. I'm going to be looking at all my zeros. That's how you call them. It's when you equal each factor to 0. And I put them at -3, at -2, at -1, at 0, at 1, and at 2. And if you have noticed, my zeros are the same as my x-intercepts. Okay, when we are talking about x equals -3, we have multiplicity 2. We said that when we have multiplicity 2, it touches at that point and then it bounces. Okay, it doesn't go beyond to the other side of the x-axis. So from here, looking at my end behavior, if it was right here, it would just touch in here and bounce. But it's going from this end behavior that I already placed. It touches the point and then it bounces. Okay, for -2, it has multiplicity 1. What does that mean? Well, in here, we don't know how far it goes, but you just turn around and go on that point. Multiplicity 1, it means just go beyond without creating a curve. If it was multiplicity 3, meaning cubed, and actually a -2, if this was cubed, then it would create kind of like a little curve, creating a flat line in here. Not quite flat, but closer to what it's a cubic function. I'm sorry. Okay, so it just goes straight. Okay, not creating any curve through that point. -1, multiplicity 2. What does that mean? Turn around, touch a 1, and bounce. With square, you just bounce. Okay, so turn around. Again, we don't know how far this one goes, but we know that it touches in there and it bounces. It creates a parabola with the vertex in there. The next one is at 0. So it's going to go through here. Yeah, and it's going to go through to the other side. Why? Because it's multiplicity 1 and it won't create any kind of point. And in here, we don't know again how high it's going to be, but we just know that it turns, crosses that point in a straight kind of manner. Then it goes through 1, same thing. It turns and goes through x equals 1, but it's multiplicity 1, so it just goes through without creating any kind of curving here. And finally, at x equals 2, notice how it has multiplicity 2, and it makes sense because the end behavior goes up, and that's all we have. So it goes around, it touches at that point, but because it's multiplicity 2, it bounces. Okay, and then you just connect it You have seen me using Desmos in the past couple of videos, so it's a free online application. And again, I'm just going to put all of those factors in here. This is just a rough graph, and we'll see how far off we are, but that's okay. What matters in here is the end behavior and the X-intercepts, which are also called zeros. Okay, so we have X times, we just open parentheses, and then we have X plus 3, X plus 3, and that one is actually squared. So close the parentheses, put the a to the second power, and then we have X plus 2, so times X plus 2, close the parentheses, open another parenthesis, X plus 1 square, X plus 1 square, X minus 1 times X minus 1, close the parentheses, open another one, and finally X minus 2, X minus 2 squared. There you go. That's what I wanted to do. Okay, so I want you to see that we have -3, 0, and it's this value, -3, -2, -1, 0, 1, and I won't be able to get to that other, there you go, and 2. So all those are our zeros, which is what we found in here. But now I want you to see the bouncing part. You can see that it's going sorry, I've been playing the guitar and that's affecting my fingertips, and so the sensibility is not good. So it goes infinitely, the end behavior goes infinitely down to negatives on the negative side of X. Also, it goes infinitely on the right side. But this is what I want you to see. And again, it doesn't look exactly the same, but at -3, it touches and then it bounces, okay? And then this will be, look, -50. So that's way different. Then through 2, it goes through 2 on a straight manner. Then it goes up, and then it touches at -1, and it bounces again, because the -1, it's a multiplicity 2. And then at 0, which is this one right here, is multiplicity 1. At 0, it just goes through because it's multiplicity 1. At 1, it's right there. It just goes through on a straight manner. When I say it in a straight manner, I mean it doesn't create the cubic curve, kind of. Okay, it doesn't. And so finally, at 2, multiplicity 2, so it touches and it bounces. So again, we don't really, we're not specific in here. And we can find these other values, but we would have to be giving different values to X, substituting here so that we can find those other values. But what we care about is actually our zeros, the end behavior, and what kind of reaction does it have depending on the multiplicity. Whew, and that was just to review last lesson. Okay, now what we need for this lesson, we're going to be working with rational functions, and this information, you will need it. It will make more sense once we start working with. So a rational function is when you have a fraction. You have something on the numerator and something on the denominator. Okay, numerator, denominator. So that's a rational function. It means you have a function on top and a function at the bottom, or numerator and denominator. So it says that if the degree of the denominator is greater than the numerator, then the horizontal asymptote will be y equals 0. What does that mean? The denominator, we have x. The numerator in here, it has x to the 0, which means 1, right? X to the 0 is 1. So whenever the denominator has a higher degree, in this case 1, and in here we have x to the 0, then that means that the asymptote of y will be 0. So in here, for this one, I graphed it, and we'll go into detail of how to do that, but in here, this is the asymptote. It means that my graph will not cross at that point, at that line. Okay, it approaches it, but it will not touch it. This is another example, 1 over x plus 1 to the second power. And so I did the graph in here, and I'm not focusing on the vertical asymptote. We'll see that in future videos. But the vertical asymptote will also go through y equals 0. It means that it will approach 0, but it will not go beyond that. Okay? The degree refers to the exponents. And so in here, the denominator has a degree 2. Numerator degree 3. So if the denominator is less than the numerator, then there is no horizontal asymptote. And finally, if the degree of the denominator is equal to the numerator, to find the horizontal asymptote, we have to take an extra step. So we wanted to watch in here, the denominator and the numerator both have degree 1. When that's the case, when the degree is the same, all you have to do is divide the coefficients of the variable. So in this case, we divide 3 by 1, and that's going to give me the answer for the asymptote, the horizontal asymptote. Okay, so 3 divided by 1 is 3. That means that y, my horizontal asymptote, is going to be at 1, 2, 3. It's going to go through there. Okay, will go something like this. Now, one thing, vertical asymptote is going to be somewhere at -2. It's going to be at -2 actually, and so this will go something like this. And I'm doing this for the explanation. Again, we'll go more in detail for other. We're just going to be working with the horizontal asymptote today, but I just had that example in there for the definition, and so I decided to show you. Okay, again, for the horizontal, just focus on, okay, divide, because these are equal, divide 3, we divide 3 by 1, and so the asymptote is going to be at 3. And now that you saw for this one, vertical asymptote cannot be crossed because it would be dividing by 0. So we're finding, when we find it by setting the denominator equal to 0. So in this example, x plus 2 equals 0. We subtract 2, and you notice that x, and I'm just going to put it here, x was equals to -2. That's why I said it's not in here. We move it to the left at -2. For the first one, if you don't have to be specific with points, these are some points that I chose. What you can do is just go ahead and forward this video. And so all you have to do is basically say y is equals to 1 divided by the value of x. In here we chose 3. And so 1 over 3 is just 1/3 or 0.33333, whichever you want to do. I'll just leave it as 1/3. For the next one, same thing, y is equals to 1 divided by the value of x, which is 2, which is 0.5, or just 1/2. For 1, it just means 1 divided by the value of x, which is 1, and 1 divided by 1 is 1. For 0, 1 divided by 0, it's not possible. Remember that you cannot have 0 in the denominator. We just call that undefined. And so, just put undefined. Y is it, and that's why we have that asymptote where we cannot touch it, okay? Y is equals to 1 divided by -1. Remember, we're just substituting x by that value. And so 1 divided by -1 is -1. Y is equals to 1 divided by -2, which is -1/2 or -0.5, whichever you prefer. and y is equals to 1 divided by -3, which is -0.333333. I forgot to put the little dash on there, or just -1/3. And so in here, we're going to graph our rational function. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And so at 3, we have 1/3. So somewhere in there. 2, 1/2. At 2, 1/2 is around there. 1, 1, 1, 1 is right there. 0, 0 is undefined, so we don't touch it. And then we have -1, -1. So -1, -1 is right there. -2, -1/2. It's around there. -3, -1/3 is around there. And we can see that our graph goes something like this. But what about the other values? We can't really see. That's all we get for our graph. So what I recommend is you choosing some of the points between 0 and 1. So maybe 1/2 and I don't know, 1/4. And we'll do that for the positives and negatives. So again, X and Y. So 1/4 and 1/2. So you can have the 0. We know that it's undefined, but when we'll choose also -1/4 and -1/2. And so we plug in again. Our function was 1 over x. So y is equals to 1 divided by 1/2, right? We're just dividing by the value of x. When we're dividing a whole number by a fraction, just put it over 1 and multiply the outer part. So 1 times 2 and put it in the numerator. And 1 times 1 is 1. And 2 divided by 1 is 2. So that's the value. When x is 1/2, y will be 2. Then do the same thing here. 1, which is this one, divided by 1/4. So we do 1 times 4 is 4. And 1 times 1. So whatever is outside, up and below, we multiply those and go in the numerator. And whatever in the inner part, 1 times 1, and put it in the denominator. And 4 divided by 1 is 4. We don't do 0. Now we're going to do this one right here. Y is equals to 1 divided by -1/4. Again, put it over 1 and multiply outside and inside. So 1 times 4 is 4. 1 times -1 is -1. And 4 divided by -1 is -4. And finally, y is equals to 1 divided by -1/2. Put the whole 1 over 1 to make it into a fraction. 1 times 2 is 2. And 1 times -1 is -1. And 2 divided by -1 is -2. So now we have those other values. And let me see if I think we're going to have to go back and forth. So for 1/2 is half of, this is 1, so this is half. We go 2. 2 spaces up is right there. 1/4 goes to 4, so 1/4 goes to 4, so around right there. Okay, and now we're able to see that our graph will be able to go that way. Again, remember, okay, something like that, and it goes infinitely on that direction. Now for these ones, so we have -1/4, so -1/4, -4, so somewhere in there, and -1/2, -2, somewhere in there. And now we're able to see again our curve, how it goes. Okay, so that's by plotting points. That's how you would find your graph. But sometimes you're able to find some parts of that same graph and be able to graph with those. We can find the x-intercepts, the y-intercept, the end behavior, and the asymptote to be able to graph those rational functions. And so how do we find the x-intercept? Well, we just replace the opposite variable with 0. So to find the x-intercept, y will be 0. And so we put 0 equals 1 divided by x. We cancel by multiplying x. We multiply on both sides. These cancel and we get 1 equals 0 times anything will always 0 cannot be equals to 1. So we say that there is no x-intercepts. It means that it's not going to go through x. And for the y-intercept, x is equals to 0. And so we say y equals 1 over 0. And that's 1 divided by 0 is not possible. We call that undefined. Again, it means that it will not cross the y-axis. Okay, so we also say that there is no y-intercept, or there is none. And for the end behavior, we can actually refer to the horizontal, because if you think about it, it's what's happening with my graph in relationship to the end behavior. What's going on with the end behavior towards the positive x and negative x. So the end behavior tells me what is going on. In here, we can see that it's the degree is higher at the denominator, because there is nothing on the numerator. That means that we have an x to the 0 power, which is the 1. X to anything to the power of 0 is the 1. It's 1. So in here, we have x to the 0 over x to the 1. And that means that the denominator is greater than the numerator. Okay, so that means that y is equals to 0. So my graph will be approaching 0. Okay, or f of x, sometimes they say. So basically, this means as x approaches negative infinite, y will be 0, or f of x will be equals to 0. And as x approaches positive infinite, y will also be approaching 0. For the vertical asymptote, we know that what we need to do is just make that equal to 0 and then start solving, and we say that that's not a possible value for x. So that's where my asymptote is. So, so in this case, x cannot be 0. It cannot be 0. So x is not equal to 0. We cannot have 0 in the denominator, and that's what creates the asymptote, the vertical asymptote. Okay, so now to draw a very rough sketch. The end behavior tells me that closer to 0, it's going to be approaching closer to 0, but then I also have a vertical asymptote at 0, and that it's approaching also at 0 on the end behavior of, as it goes infinitely on x, it approaches. There is no x-intercepts or y-intercepts. It means that it never crosses that x or y. And so my graph would go something like this. Never touching the x or y intercepts. And for this one, it would just be something like this. And that's actually, it comes from a mother graph. 1 over x will actually look like this all the time. And there is going to be transformations when you're adding or subtracting, but you'll see that with the next example. But overall, when you have 1 over x, that's my mother graph on quadrant 1 and quadrant 3. So a recap: to find the x-intercepts, you just replace y with 0 and start solving for x. For the y-intercept, you replace x, the other one, x with 0, and you start solving for y. For the end behavior, if the degree of the denominator is greater than the one in the denominator, then y will be equals to 0. If the degree of the denominator is less than the numerator, there is no horizontal asymptote. And for the vertical asymptote, you will just make the denominator equal to 0, solve for x, and the value that you get, that's where your vertical asymptote will go. Okay, so that's just a recap, and let's try a different one to see if that makes it a little bit more clear. For number 2, I'm going to create a table as well, but first a rough sketch with the information that we get from here. And so again, to find the x-intercept, y will be equals to 0. So I'm all doing is replacing y with 0 equals 1 divided by x plus 3. Multiply times x plus 3 on both sides. These cancel and I get 1 is equals to 0 times anything is just 0. And again, 0 is not equal to 1, so we say no, there is no x-intercepts. What does that mean? That it's just not going to touch the x-axis. For the y-intercept, we have x equals 0, so we put y equals 1 divided by 0 plus 3. So y equals 1 over 0 plus 3 is 3, so it's at 1/3. So we say that x is 0 and y is 1/3. For the horizontal asymptote, the degree on the denominator, which is 1, is greater than the degree of the numerator, and it's because we have x to the power of 0. Okay, so since that's the case, that means that the horizontal asymptote is at y equals 0. So y equals 0. It just means that the end behavior is x. As x approaches positive infinite, it goes f of x, or y, will go to 0. And the same for the negative. When it approaches negative infinite, then the end behavior, or f of x, is going to approach 0 as well. Now for the vertical asymptote, remember that we just put whatever is in the denominator, so x plus 3 equal to 0. And we start solving for x. So if we're adding 3, the opposite is to subtract 3, and x is equals to -3. So the vertical asymptote is going to be at x equals -3. And now with that information, we're able to graph a rough sketch. So let's start with the vertical asymptote. Vertical is an asymptote. So -1, -2, -3. Sounds like like I'm rewinding a record or something. Okay, so it's going to be right there. That's my vertical asymptote. The horizontal asymptote is at y equals 0. So y, we put it at 0 and say, yeah, it's right there. Okay, that's my horizontal asymptote. And it goes infinitely, or it approaches 0 on negative infinite and positive infinite. Okay, it also says that the y-intercept is at, so if we go like this, it's going to be at 1/3. So 0, 1/3 is around there. Okay, and I know this should be closer to the x-axis, not flying up there. Okay, so at 1/3, and if you recall, if this is a positive of the mother graph, then it's going to go like this. And then on the third quadrant, it just shifted because we're adding 3. Okay, and so it will go something like this. Remember that it means that it's approaching those asymptotes, but they never touch. And the same in here. So something like that. And so that will be my graph with the vertical asymptote and the horizontal asymptote, my y-intercept. And there is no x-intercept, it means it doesn't cross in there, okay? I chose these points, and let me show you how I choose. How do I choose these points? I try to guide myself with the vertical asymptote, and it's just by solving this equal it to 0 and solve it. So if we're adding 3, the opposite is to subtract 3, and so it will be x equals -3. And closer to this point, I will just add 0.5 or 0.25 if you want to be more specific. You can just do adding and subtracting 0.5 on both sides, but I prefer to include this one where you add and subtract 1/4. Then you go with the whole numbers, because that's going to give you more points that are closer to what you're looking for. And you can start from the very middle, or you can start from over here. In here, usually this means that's a vertical asymptote. It means it's not possible because -3 plus 3 gives you undefined. It doesn't give you, that becomes 0, and 1 divided by 0 will always be undefined. Okay, so this middle point, undefined. You will always get undefined because it gives you a 0. And that's not possible to have in a denominator. From there, I start solving. So y is equals to 1 divided by -3 1/4, and you can put -3.25 is the same thing, plus 3. And I put 1 over, if you see, I have -3 and +3, but I also have a -1/4, so the 3 cancel, but I only have -1/4. And we put it over 1. 1 times 4 is 4. 1 times -1 is -1, which gives me -4. See, those are the numbers that give me really real points closer to that asymptote. That's why I like to use them. Y equals, again, I'm going to put 1 divided by -3.5 or -3.5 plus 3. The -3 and the +3 cancel, so I only end up with -1/2 in the denominator, so -1/2. I put it over 1 and multiply. 1 times 2 is 2. 1 times -1 is -1. Don't forget the sign. Okay, so 2 divided by -1, and 2 divided by -1 equals -2. Okay, so I have that other value. For the next one, I have y is equals to 1. Now I have whole numbers, or integers actually. So x is -4 plus 3. 1 divided by -4 plus 3 is -1. And 1 divided by -1, -1. The last one, y is equals to 1 divided by x plus 3, but x is -5 plus 3. I have -5 and +3, that's -2. And 1 divided by -2 is just -0.5. -0.5, or I prefer to leave it as -1/2. Now the next part is going to be y is equals to 1 divided by the value of x, which is -2 3/4 plus 3. And that gives me 1 over, well, think about it. I have 3 cakes, but I'm taking away 2 3/4. So what do I have left? 1/4 of that last cake. I take away 2, and of the last cake, I take away 3/4. I only have 1/4. And it's positive because the bigger number is positive. I put it over 1 and start multiplying. When we're dividing, remember it's just the law of the shoe horse. This looks like a shoe horse. And the outer part, you just multiply. 1 times 4 is 4. 1 times 1 is 1. And 4 divided by 1 is 4. For the next one, y is equals to 1 divided by negative 2 and 1/2 plus 3. 1 divided by, again, we have 3 cakes and we're taking away 2 and half of the third one. So I'm just left with 1/2. We put it over 1 and multiply 1 times 2, 2, 1 times 1, 1, and 2 divided by 1 is 2. And that's for this one. For this one down here, y is equals to 1 divided by negative 2, and 1 divided by negative 2 is negative 0.5, and I just prefer to leave it as negative 1/2. And the last one, y is equals to, rewind. I did not add the 3. Notice how it helped me to see negative 4, negative 2, negative 1. Why am I getting negative 1/2? I noticed that I did not add the 3. So 1 divided by negative 2 plus 3 is 1. And that's equals to 1, not negative 1/2. So it's 1. 1 divided by negative 1 plus 3. And 1 over 3 minus 1 is 2. So that's 0.5 or 1/2. Either one is fine with me. Ask your professor what they would prefer. Okay? So 1/2. So let's focus over here on the negatives for x. And then we say 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. And then negative 1, negative 2, negative 3, negative 4, negative 5. And so we begin by putting negative 5, negative 1/2. Negative 5, negative 1/2, somewhere in there. Negative 4, 1. Negative 4, negative 1. So negative 1 is right there. Negative 3.5. 3 and 1/2, and you have negative 2 on y right there. Negative 3 and 1/4, negative 3 and 1/4, and it's negative 4 in there, so around there. And so that's where our graph will kind of go. For this negative 3 undefined, it just means that it will never touch that point, and that's where my vertical asymptote will go. Okay, that's why it says undefined. It will approach it, but it will not touch it. Also, from the rule, because it's heavier, it's higher degree at the bottom, the denominator is higher, greater, y is 0. Okay, so what does that mean? It means that my horizontal is going to be a y equals 0. Just means that it's going to be right on the x-axis. So it never touches right there. Okay, so negative 3. Okay, for the next point is negative 2 and 3/4. 3/4 just means cut the next one in fourths and get 1, 2, 3 right there, and go 4 spaces to the positives is right there. Negative 2 and 1/2, negative 2 and half of the next one, positive 2. Right there. Negative 2, positive 1 is right there. Negative 1, positive 1/2 right there. And so this doesn't look quite, but it's something like this. And if you remember, the y-axis was at 1/3, so somewhere in there. Okay, so again, you can find the y and x axis and the two asymptotes and graph it or you can find specific points, whichever it's needed from you. Okay, for the last one, let's just start with finding the quick information for a quick sketch, a very rough sketch. And so again, for the x-intercept, y equals 0. So 0 equals x over x plus 3. If I'm dividing, I multiply times x plus 3. This cancels and you get x equals 0. So that means that my x-intercept is a 0. So x is 0, y is 0. Now for the y-intercept, x equals 0, so y equals 0 divided by 0 plus 3, 0, 0 plus 3 is 3, and 0 divided by 3 is 0. So again, I replaced x with 0, and the answer for y was 0. Let's look in here. So for the horizontal asymptote or end behavior, it says that we need to look at the degrees. The degree is 1 and the degree is 1. So they are equal in the denominator and numerator. How do we find the horizontal asymptote? We have to divide the coefficients. Like in here, we divided 3 by 1. In here, we're going to divide, the coefficient is 1 and 1. Again, we have x on the numerator, x in the denominator, the degree is 1. But what we look at is the coefficients, which is 1 and 1. And 1 divided by 1 is 1. Okay, so the horizontal asymptote will be at 1. Now, if we're talking about the end behavior, it means that as x approaches negative infinite, f of x will approach 1, or it will get close to 1. And as x goes towards the positive infinite or approaches positive infinite, f of x will also go towards positive 1. For the vertical asymptote, what you do is get whatever is in the denominator, so x plus 3 equal it to 0. Then you solve for x, and 0 minus 3 is negative 3. So that means that the vertical asymptote is at negative 3. With that information, we can just create our sketch. And we start by creating our horizontal and vertical asymptotes. The horizontal is a positive 1. So let's do 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then the horizontal is a 1. A very straight line, please. And then the vertical is at negative 3. So negative 1, negative 2, negative 3. It's right there. Those are the asymptotes. That means that our graph approaches them, but they do not go beyond that line. So we know that it goes through 0, 0. And that kind of guides us, okay, so if that's the case and we know that it's approaching 1, then that means that it's not going to be like this and like this, but rather on this side. These are the ones that guide us, okay, since it goes through here, it has to be in this new quadrant per se of the two asymptotes, the vertical asymptote and the horizontal asymptote. That kind of becomes our origin. So it goes through here, it approaches this asymptote, and so we can say that it's going to go something like this. And it's very a very rough sketch, but we'll see with the table how it looks. Okay, again, the x and y intercepts are the one that guide our graph, knowing where in the 4 parts of this new coordinate plane is. Okay, and so the same thing would be in here, where you know that your graph will be somewhere in here, approaching those asymptotes but never crossing them, and so that's what your graph would go. Okay, the X and Y intercept guide us to know in what quadrant we'll be touching our graph, and then it just mirrors. Okay, so Y is equals to -5 divided by -5 plus 3. I forgot the minus in there. And so -5 divided by -5 plus 3 is -2. Again, how did I choose these points? It's just by looking at the asymptote. Okay, it's the vertical asymptote, which is where on X will it be that vertical asymptote by solving this for X. So X plus 3 equals 0, subtract 3, and that's my value right there. So -5 divided by 2 is negative divided by negative becomes positive, and 5 divided by 2 is 2.5 or 2.5. Okay, whichever you prefer to use. For the next one, I'll do one with one color and one with the other so that it's easier to identify. -4 divided by -4 plus 3. Remember, we're just substituting X and X by that value. And so -4 divided by -4 plus 3 is -1. Negative divided by negative is positive. 4 divided by 1 is 4. Y is equals to -3 and 1/2 divided by -3 and 1/2 plus 3. So that's -3 and 1/2. The whole number cancels with that part of this mixed number, the -3, so you just end up with -1/2. I'm going to convert this to an improper fraction, I'm sorry, and we multiply 2 times -3, -6 plus 1. We know that this is negative. 2 times 3 is 6, 6 plus 1 is 7, 7/2, divided by -1/2. Negative divided by negative is positive, so you can cancel that right now and then just multiply the outside with the outside, the inside with the inside. And 7 times 2 is 14, 2 times 1 is 2, and 14 divided by 2 is 7. For the next one, Y is equals to -3 and 1/4 over -3 and 1/4 plus 3. So it's negative. Let's do the mixed number already. So we know that it's negative. 3 times 4, we always multiply the denominator times the whole number. 3 times 4 is 12, and add the numerator. 3 times 4 is 12, plus 1 is 13, and the denominator stays the same, over, cancel the -3 with the +3, we just end up with -1/4. That -1/4 still there. And we multiply the outside with the outside, the inside with the inside. Negative times negative, positive. That's why they cancel. 13 times 4. In here you can do two things. If you multiply 13 times 4, is 52. So you can put 52 divided by 4 times 1 is 4. And then divide 52 divided by 4 gives me 13 again. But the other thing that you can do, and I'm just going to do it in here, is 13 times 4, I just rewrite it. 4 times 1, I just rewrite it and cancel that. And 13 divided by 1 is 13. In here, we already know that this is undefined. Why? Because if we get -3 over, -3 over -3 plus 3, -3 plus 3 is 0. We cannot have 0 in the denominator because that will always be undefined. Okay, we cannot have that in the denominator. Okay, for the next one, Y is equals to -2 and 3/4 over -2 and 3/4 plus 3. Keep the, we can multiply already. Multiply and add. Multiply and add. Actually, I say it's a backwards C. So in here, let me show you how I do it when I have it nice and organized. So it's a backwards C, and you multiply and add. So 4 times 2, 8. 8 plus 3, 11. And keep the denominator, and you just bring over the negative. So negative 11 fourths. 4 times 2 is 8, plus 3 is 11 fourths. And it's negative because you just keep it. Over, you have 3 cakes. You eat 2 cakes and 3/4. That means you just have 1/4 of that cake. And because the positive is bigger, the 3 is bigger than the negative 2 and 3/4, you keep it positive. Now, negative divided by positive is going to be negative. 11 times 4. Remember, we can do that already. So 11 times 4 divided by 4 times 1. 4 times 1. The 4 divided by 4 cancels because it becomes 1. And 11 divided by 1 is 11. Negative 11. But if you want to see the whole process, negative 11 times 4 is negative 44. Over 4 times 1 is 4. And 44 divided by 4 is 11. But we bring over the negative. Or you can say negative 44 divided by positive 4 is negative 11. Them in order. So negative 2 and a half over negative 2 and a half plus 3. We multiply, we know it's negative. 2 times 2, 4, plus 1, 5. Keep the denominator. In here, I have 3 cakes, but I eat 2 and a half. I'm left with 1/2. Multiply the outside, multiply the inside of the shoe horse. Negative 5 times 2 is negative 10. 2 times 1 is 2. And negative 10 divided by 2 is negative 5. Or you can just do what we did in here. So that's negative 5. For the next one, y is equals to negative 2 over negative 2 plus 3. Negative 2 plus 3 is positive 1. Negative 2 divided by 1 is negative 2. And finally, 1 is equals to negative 1 over negative 1 plus 3. Negative 1 plus 3 is positive 2, which is equals to negative 0.5, or just leave it as negative 1/2. Let's create a more accurate graph than that one. Let's try at least. Okay, on X you need negative 5 to negative 1, so we're going to try to do them more on this side. Negative 1, negative 2, negative 3, negative 4, negative 5. And then on Y, you need up to 13 and lower, as low as negative 11. So that's going to be a challenge. We're going to make them a little closer. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Barely made it in there. And then for this one, as low as negative 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Negative 11. Okay, so we have negative 5, 2 and a half, negative 5, 2 and a half is right there. Negative 4, positive 4, so around there. Negative 3 and a half, 7. So in here it's 2, 4, 6, 7, around there. Negative 3 and 1/4, positive 13, somewhere around there. And then remember, undefined just means that my vertical, it's going to be my vertical asymptote. It's going to go through there. Means don't touch me. I'm just kidding. And so and then for, what did we say for the horizontal asymptote? Well, whenever the degrees are the same, 1 divided by 1, 1 and 1, they're equal, we need to divide the coefficients. 1 divided by 1 is 1, so the asymptote in here is at 1. Okay, my horizontal asymptote is at 1, and so it never touches in there. It approaches 1, but it never crosses it. Now for the other ones, let's start looking for the points. -2 and 3/4, -2 and 3/4 is right there, so it's -11. Around there, it's right there. -2.5, it's -5, so around there. -2, -2, -1, -1/2. So somewhere in there, and again, my graph goes through those points, approaching those asymptotes by never touching them. Okay, and on this side, approaching the horizontal at +1, but never touching it. And so look at the difference between those two. Kind of. So these are the two different ways of finding those graphs, with just sketches that approaches them and with the table. Again, in here, to be able to know in which side of the graph it would be, you guide yourself with the X and Y intercepts, and that way you know, oh, if it touches the X and Y intercept is in here. If it was in here, then it means that it would be something like that, and then the other one would be in here. But guiding yourself with the X and Y intercept, but then never crossing the horizontal and vertical asymptotes. With this, we end our lesson. If you can please give us a
like,
subscribe around here. This is the list to the entire unit. Here you will find the next lesson. Now you're able to do 7.4 and
fun. Wait.
Okay. Otra vez.
Have fun.
Now you're able to do okay.